All right, example number 10. We're kind of flip-flopping the thing that we had before in the last example to a small extent. Actually, no, it's exactly flip-flopped. How about that? All right, so we have x squared times sine of x inside the parentheses, all raised to the x power. And thankfully, when we take logs of this thing, it's going to simplify beautifully so that the derivative is at least relatively easy, or at least the product rule is simpler. So let's see how this works out. So we're going to set y equal to our function, x squared times sine of x to the x power. And then what are we going to do? We are going to take logs of both sides so that I have natural log of x squared sine of x raised to the, raised to the x. I just got to make sure I get all my parentheses right. Okay, now what we're going to do is use our log rules. The first thing that's happening on the inside of this logarithm is this exponent here, because it's the entire set of parentheses raised to that exponent. So that's going to come down in front. So the challenge of this problem is more or less just making sure you use your log rules correctly. So that x comes down in front. So we have x times, natural log of x squared times sine of x. All right, are we done with our logarithm rules yet? Nope, because we have a product happening on the inside here. So we're going to turn that product into a sum of logs. We got to be very careful to make sure that we are consistent with this x out in front. One way to do that is to just put a box around where your logarithm was. So we have x times natural log of x squared plus natural log of sine of x. Okay. All right, so are we done with our log rules yet? Nope, because we have in the first log this x squared. This 2 could be moved down in front of this log. So writing that out, we have x times 2 natural log of x plus natural log of sine of x. Can't really do much with this natural log of sine of x. Okay. Now, are we done with our logs? Thankfully, yes. Okay, so in order to derive this thing now, you have two options. You can either take this x and FOIL it through, so you have to use the product rule twice, or you can do the product rule once, keeping the x exactly where it is currently. So why don't we do it that way? Why don't we just leave this x in front? So we have two functions that are being multiplied together, namely this x and then this giant box. So deriving both sides, we have y prime over y. Derive the x. So you get 1. Leave the thing in the box alone. So you have 2 natural log of x plus natural log of sine of x. And then you add on. You don't derive the first thing, so you leave it as an x. Then you derive the second thing. All right, so how do we derive this thing that is purple underlined? So the derivative of 2 times natural log of x, well, the 2 just gets carried along through the derivative. So the derivative of natural log of x, as you know, is just 1 over x. So I'm going to put this all in a giant box, just so we're clear what we're doing. So it'll be 2 over x for the first term, this guy. Then plus, okay, now we need to derive this natural log of sine. So that's 1 over sine of x times the derivative of sine, which is just cosine. Oops. Let me rewrite this on top. Save myself a step later. Okay. Is there a little bit of simplification that we can do here? Yeah, a little bit. But we're not going to worry about it. So like you could distribute your x through this thing and cancel a few of your x's off, but I'm not going to worry about that. Instead, since I've derived the right-hand side completely using the product rule, I'm going to put a big box around it and then multiply both sides by my y, so I can get my y prime by itself. So this whole thing, should be multiplied by y. So what do I get? I get y prime is equal to this giant box of, okay, so this 1 doesn't matter, so I'm left with 2 natural log of x plus natural log of sine of x in this box, and then I have x times this other box, 2 over x plus cosine of x over sine of x in this bigger box. And then we multiply this by our y. Our y originally was this function, this x squared sine of x to the x power. So that is what we're going to write here. Let me move this dot to the next line. So it's clear that this giant box is just getting multiplied by the original function y. And then that's the final answer. Big old box times the original function. Not pretty, lots of writing, but the method remains exactly the same throughout every single one of these problems. Hopefully at this point things are starting to click for you. If you haven't gotten a chance to try all the examples yet, make sure you do. Make sure you have this mastered because it's a very, very useful technique.